And welcome back. Now today we're going to be revisiting a favourite circuit of mine using the two MOSFETs for power on off, but there's a special reason for doing that. Yeah, and oh yeah, last week of course I wore those glasses, which actually there is a serious side to that. They're sunglasses, so they protect me from the glare of the video lights, and this eye particularly is quite sensitive. But I got a lot of flack saying, you know, it's an Elton John party from the 70s. So this week we're going to take a much more serious approach, because after all this video is a fairly serious channel, isn't it? All about Arduino and electronics. So no more mucking about. So this whole video came about because I had a comment from Ivo. I think you can pronounce it like that. There it is, look on the screen, Ivo, and he says, Ralph, take a look at the LTC2954. He says it's sort of complementary really to the push button, to the FET technology, the MOSFET technology that you've been using for auto switch off. And this 2954 is sort of complementary in as much that you have a push button to switch something on and then a push button again to switch something off. And I thought, that's how a lot of things work, isn't it? When you think about it, you go up to a device, whatever it is, radio perhaps, you just press a button that says on and it springs into life, and when you've had enough you press the same button and it cuts off again. So I thought, I wonder if this circuit down here could be made to do that without any sort of additional mucking about with separate switches. I mean, yeah, it'd be very easy, wouldn't it, to have two separate switches to make it on and off. But I'd like to keep the single switch. Oh, you want to see the circuit diagram? Obviously, okay, let me get that up first. I want to give a shout out to my sponsor, JLC PCB, manufacturers of custom PCBs, made simple. One of their new features that's coming up shortly is their SMT assembly process. And their webpage contains a lot of information about what their capabilities are and some various very common facts. If you prepare your PCB using Easy EDA, you'll find that when you place components, you have the option of using their LCSC assembled catalogue. As you can see here, I've just chosen the IC that I'm going to be using in a future project, and it's come up as part of the LCSC assembled list. That means they can pick and place it for you on that board. If you can, try and use their basic list rather than the extended list, which means they'd have to change the components in the pick and place machine. Designing a board could not be easier using Easy EDA. And the fact it links into the JLC PCB website is going to make ordering an assembled SMT PCB an absolute breeze. Why don't you try them out today? So this is the circuit that we've been using all along, and the single switch on here, which you can see there, is just, all it does is bring that gate down to ground. So it switches this P-channel MOSFET on temporarily while the Arduino or whatever microcontroller you've got is in between these terminals here where it says load, and that then sends a signal out to this MOSFET to turn this on and therefore keep this gate down to ground. So it's an auto lock on really, I suppose. But what we wanted to do then is to say, well, how can we have this switch here also used to indicate to the microcontroller that we're using, we'd like to shut down now, please. So it'd be a controlled and graceful shutdown. Okay, well, let me put up a new picture and we'll see how that works. Right, there we are. That's the revised circuit. Now you can see there then that all we've done is added in a couple of diodes and a connection to the microcontroller. The pin 2 that we're using is going to be brought low via the fact we've pushed the button, as you can see there, and that allows with that diode a path down to ground, and that's enough. This is a simple 1N4148 diode, not a problem at all. And the other diode going to the gate now, before the switch, although there is internal resistance of course, easy for me to say, there is internal resistance of course on that gate. And sorry, I'm just looking at my reflection. It's just stupid, isn't it? And that resistance is okay. There is some few hundred ohms, but it's still insignificant for that MOSFET to allow that path to the gate and still be switched on temporarily while we push the button. Right. So that was the only two modifications that I did in the hardware. And in the code, well, it's fairly standard and straightforward. So let's Well, let's have a look at it working. I've got it all set up on my desk here. Now, it's a little bit tricky showing you in the debug window, the serial monitor, this all working, because obviously at the moment it's dead. So I can't get a serial monitor up and running because there's nothing to show. The monitor only will work when there is a port, a common port, to look at. So it's going to be a little bit pushing the buttons and trying to get the monitor working, but we will get it, even if it's, you know, after the event. Right, let's try that next. Right, now I'm going to have to push this button here to turn it on, as we always have had to do. But now, apart from holding my finger on there for a few seconds until it all fires up, I'm going to have to frantically jab the connect button on this monitor window here to see if we can get connected to the port. So let's have a go. So push the button. It all springing into life. I'm going to say connect, come on, connect up. It's not going to, is it? It's thinking about it. There we are, it's connected. Set up, started, great. So what that now tells us is we've pushed the button long enough for the Arduino to fire up, and then set that gate high on the N-channel MOSFET to keep it all running. So that's what it's saying here. It's saying, okay, we've established the power. Let's just move that window over a bit so you can see a bit more. It says the shutdown requests are not yet accepted line. That means I'm not going to accept anything on those interrupt pins yet. One, because I haven't executed the code to actually detect the interrupt. And secondly, whilst my finger's on this button here, we don't really want that to be detected as an interrupt. It's shut down already. I'll tell you, this breadboard is from hell itself. You just breathe on it and something goes wrong. It's just, oh. Anyway, so only after a few seconds will it allow you to press this button to switch things off, which obviously you saw, but that wasn't the intention. I wanted to actually press the button. So let me just fire that up again. Right, there we are. It's all fired up again. Now, if I press that switch again to shut it down, you'll see that it's going through some motions here as though it was actually doing something, you know, writing something perhaps to an SD card, sending out an email perhaps, or some kind of alert or something to ThingSpeak, anything of that type to make it graceful, as an app would, you know, on your Windows PC or Mac PC. Windows doesn't, when you say restart my machine, Windows doesn't go bang and just kill everything at a stroke. It says, no, oi, you applications out there, I'm sending you the shutdown command and you do your thing, whatever that means. And that's exactly now what we're doing in the Arduino. So let's have a look at the code, and then we're going to come back to the actual 2954 from Linear Technology to see how that does it. Okay, this is the simple code then. I mean, it's really very straightforward, but does give you that push on, push off facility using that same circuit. So what have we got? I've got to be honest, it's difficult for me to read at this distance with these eyes, but basically, okay, the include Arduino bit you don't need unless you're running on a non-standard platform. In fact, that's already included for you if you're using this on the Arduino IDE. Now we're defining our enable pin, that is the pin that goes high to turn that gate on to keep the thing all running, as pin 14, which is A0 as well. But as we're using it in a digital mode, it just doesn't make sense to say A0, does it? It's actually pin 14. And the interrupt pin, as I said before, we're using on pin 2. So that's the pin that gets the pulse to ground when you press that button the second time around. To say, oi, do something. Now you might be thinking, hang on, what about the first time when we're powering up? Remember, we're not looking at an interrupt at that point. We haven't told the code immediately upon power up, go and check your interrupts. No, we're saying, I'm not accepting interrupts, okay? And you'll see that in a sec. So the setup says, right, the very, very, very first thing it does then is turn on that enable pin to keep the whole circuit latched and running. Okay, so it does that before anything else. And even then there's a rather annoying delay because of that blasted bootloader. I should have really reflashed this board without a bootloader so it'd immediately jump in. Because what it's doing when I press the power button now and the thing fires up is that the Arduino is taking, I don't know, 1 to 2 seconds running the bootloader, which is inspecting the USB port to say, anybody loading a sketch at the moment? No, I'm sure, no sketch. All right, then I'll run the code. which is fine under normal circumstances. But when you want something to really jump in there, that bootloader can be quite irritating. And I told you before that I took off the bootloader on my toothbrush timer, and it's instant now. You turn it on and it springs into life instantly. And I think that's probably a good way to go for final code. When you're debugging, you probably want to keep the bootloader on so you can upload via that USB. But afterwards, you might want to rethink that. Anyway, moving on then. So what we're saying is, right, we're starting up the debugging port, sending out a few messages about what it's accepting. Now we're doing the interrupt pin here. Now Arduino do say you should really set your interrupts to inputs and ideally pull-ups. Pull-up in this case anyway, because we're looking for a low value. So if we've pulled it up already to high value, that's fine. And then we're saying now check that pin when it goes low. So that's what we're doing there. And in the loop, what we're saying is, if we've been around for at least 5 seconds since the very start of this program, so millis when you start the program, the sketch is always going to be 0. There's no point in taking a snapshot. We know it's going to be 0. And it says, have I had a shutdown request? Now, if there's a shutdown request in the interim of those 5 seconds, it will just ignore it. I'll show you that in a sec. So it says, okay, I've been around for 5 seconds and I've not had a shutdown request. So we'll enable the flag that says, all right, I'll accept shutdown requests from now on, and just display that, and then wait. This bit here, I'll put this in. I don't think this is strictly necessary. Basically, it means get your finger off that button, because I'm holding that button down, holding it down, waiting for it to latch. But of course, it's shot through the code by that time, by the time I realise, and I'm still holding that button down, which could then, after 5 seconds, be interpreted as a shutdown. So at this point, it just hangs at that point, but I think there's probably a better way to do it. But for demo purposes, it's probably okay. As I said before in a previous video, I often put little beepers and things in my projects just so I can tell what's happening. So if I'd put a beeper on here, a simple 5-volt active beeper between any GPIO pin and ground, and beeped at the very start of that setup routine, so as soon as the power pin was enabled to keep this thing latched and powered, I know I could take my finger off at that point. But well, in the interest of simplicity, really, I just didn't do it this time. But in real life, I'd be quite tempted to do that, I think. So that you imagine what happens. You come to this unit, this powered down, you want to start it up, you press the button, it goes beep, and at which point you take your finger off. That sort of feedback is always very useful for users. You could do it on screen or a little monitor or whatever else if you've got one as part of the project anyway, but a beeper is, you know, 30 cents or whatever they sell for, and it's a good little thing to have. And you can use it for other things then, you know, alarms or whatever. Okay, the other thing the loop is checking for then is saying, have I had a shutdown request and I'm allowed to have a shutdown request? So both things have to be true, and it goes, okay, I'm shutting down now, and these bits here are basically just pretending to do some cleanup work. So if you're logging the temperature of a beehive, for example, you don't want it just to kill it bang like that, because your SD card will just be corrupted. They're very picky about things like that. So what this is pretending to do is now saying, okay, I'm finalizing the SD card, making sure that's all shut down, and maybe powering off another bit of the circuit or whatever, and then finally shutting down. So it's a graceful shutdown. This else resets the shutdown, but I don't think that'll ever going to be executed. It was just while I was creating this sketch. I think we could probably remove that now. Yeah, and this is the interrupt, this little one-liner here. So what we're saying is I've attached the interrupt to that pin back in the setup. So this line here attaches the interrupt. So from that instant on, it's looking for a low on that pin. And when there is one, it jumps to this interrupt here, which I've told it that name, that power int ISR, is what I put it in as here. There it is. See that? It's an arbitrary name. You can make it whatever you want, but it's useful to make it at least reasonably, you know, meaningful. And I've just said, yeah, I've had a shutdown request. Now, as I say, that could happen the instant after that statement is executed up here. But that's within the 5 seconds, and we just want to basically ignore that. So what I'm going to do is go back to the workbench now and show you what happens when I press that button in that interim period. Let's see if we can get that to work, shall we? Right, okay, I'm going to press the button, It's all fired up. I'm going to take a guess at now. Oh, too quick, powered off. See, this is what I mean about that bootloader. It does get in the way of things. Try again. Powered up. Must be. Now you notice there I pressed it 3 times. I hope you heard the clicks, and nothing happened. It didn't shut down because it's within that 5 seconds, which is always a useful thing to do. But now if I press it, it's going to shut down after. Now, bink, off it goes. Great. Now, okay, so we've got this working. The code was, well, I'm not going to say trivial, because no, it's not if you're a beginner to the Arduino world. This is a good little introduction into interrupts and how you can control things like that. The circuit, the hardware circuit, is simply a modification of one we've used before. So yeah, it's a fairly straightforward project, I suppose, if you're going to implement this to any other project. I wouldn't use 2 MOSFETs like this in the proper project, of course. I mean, this will handle lots of amps, and we certainly don't need an N channel anywhere near as big as that. Last week I showed you that little tiny MOSFET pair, the dual MOSFET, in one little tiny chip, but I've got a couple of others still sitting in my drawer there, waiting. And when I can see again, I'll get those out and we'll play about with those and see how well they work. Because obviously we want enough current to be able to pass through them to power the Arduino, or the chip anyway, assuming, well, you might be using a whole board like this or a nano, and any other peripherals. But we don't want them huge like this where they can take, 20 amps. That's just nonsense, isn't it? Right, let's have a look at the actual product we're trying to emulate here. And why am I even doing all this? Good question. So this is the datasheet for the Linear Technology LTC2954, the very device that Ivo brought to my attention, and it looked pretty good. You can read this in your own time. I'll put it up obviously in the GitHub and the description link downstairs. So let's just scroll down a bit. You'll see the circuit. Now this is the circuit on the left that I was interested in. Now the device is only this little thing, and it's got this little push button here. Fine. But it does still need a P-channel MOSFET here. I think, oh, so we haven't actually saved very much then, have we? I mean, and then the interrupt pin and the enable pin and all that stuff is on here, and that's as you would expect. However, we still need this P-channel MOSFET here anyway, a single one, not a dual one then in this case. And push it once, it starts up, push it again, it triggers the microprocessor with this int. Yes, it is a low pulse, that's fine. And the kill command that you would normally give out from your microcontroller would be sent back to this device to shut down this MOSFET. But we're all doing this. What we're doing, instead of sending out a kill command, we're just not sending out a value on that pin 14 to keep the whole thing alive. Okay, fine. I thought, yeah, this is quite nice. And there's another feature on it that I quite like, which we won't cover today. In fact, I'm going to skip over it in case you happen to read it. I thought, yeah, okay, I quite like this. I think I might get a couple in and just play about and see what we can do with it. So I thought, well, okay, I want it fairly quickly then if I'm going to get it before Christmas. Let's go to radio spares and see how much they're selling it for there. Right, so this is radio spares, and it says £3.32 before VAT. That's the tax in the UK. Oh, hang on, and you've got to buy 2 of them. So that's like £7, £8 really after tax for 2 devices. I thought, you've got to be joking, haven't you? I thought, no, that's just too much. Are there any hang on, there's a cheaper one, like £2.16. Oh, but I've got to buy 500 of them. Yeah, and so it goes on, right? So I thought, no, £3.32 plus VAT, and you've got to buy 2. I thought, unless you're desperate for this chip and you're writing or creating a commercial product, I doubt you'd spend that sort of money. I wouldn't, all right? So if I'm fairly typical, yeah, I know, fairly typical with these on my head, but I wouldn't spend that sort of money. So, okay, I thought, well, we know where to go for cheap stuff, don't we? Aliexpress. How much do they sell it for? Let's have a look. There we are. Hooray, Aliexpress. Hang on, what's this? $10 for 5. That's $2 a piece. Okay, $2 is closer to what I expected. Frankly, I expected 50 cents. I've got to be honest. $10 for 5, even though they only show 4 there, so it is a lot of 5. But I don't want 5, frankly. 2 would have been enough at that price. Oh, hang on, my headset's fallen off. Yeah, I know, it's Christmas. All right, just gloss over it. Yeah, okay, it shows 4 here, but it does say lot of 5. $2. I would have bought 2 at $2 each, so maybe, you know, $4 with free shipping. But $10, I don't make that much money on an entire video in a month, so no, I think that's too much. There it is in all its glory. It's still quite expensive for what it is. I thought, well, hang on, we're already halfway there. This is where the thought process led to. I thought, well, we're already having an auto switch on. Can I do an auto switch off as well? And lo and behold, as we've just seen, yes, we can. So at no extra cost. Well, I say no extra cost. It's, you know, 2 diodes, isn't it, and a tiny bit of code. All right, an interrupt pin as well. But what I'm saying is we can do this with minimal outlay. We certainly don't need to spend $2 on a chip. However, there is one thing that the LTC2954 gives us that I haven't yet implemented, mainly due to time constraints. And also I'm starting to think, is this going to be over-engineering it? Well, let's go back to the LTC datasheet. And the one thing it says, well, the thing that is of interest, let me just zoom in on this a little bit. There we are. Now, this capacitor down here, which they've put it as 1 microfarad, and it says the time power down timer 6.4 seconds. What's that all about? Is this an extra feature? Yes, it is. What they're saying is you go up to your device that's running quite happily, or perhaps it's not running, it's sort of alive, the power's on, but nothing much seems to be happening. So your B counter or temperature logger or whatever just hung. And okay, normally you'd get around that by using a watchdog timer. So if your processor doesn't keep resetting that watchdog timer, easy for me to say again, watchdog timer every few seconds, it would reset your processor anyway. In fact, I've had it in the past where if you're listening for an SPI response and there's something odd going on the device that you're supposed to be sending it back, you'll sit there forever. It doesn't time out. So yeah, that sort of thing it can handle. What it says is, if you then press that button again, but for a long period, well, defined by this and that capacitor, this will just kill this MOSFET. Okay, so you press the button, hold it in, 6.4 seconds or longer, well, or shorter, depending on how what value capacitor you choose here. You keep pressing it in, and eventually it just goes, kills it. Which is, once again, sort of what we expect from objects, you know, electronic objects around the house. I've had that where you've had to press things in. A reset button almost, isn't it? Whether it's, you know, video cameras, webcams. I don't know if the Amazon Echo's got one or not. But that little tiny pinhole that you have to press something in, hold it in for up to 10 seconds, in fact, and then it either springs into life or reboots itself or whatever. We could therefore do it with another switch in addition to the one they've shown here, but I'd rather use the same one we got. The other thing we could do, instead of having a single pole switch, of course, is have a dual pole switch, single throw. So you get 2 switches in parallel, operated by the same plunger movement or switch movement, but they're totally independent. So one could be turning it on and off as you'd expect, and this other one could be used for something else, and it doesn't then have to bring that power down to ground, which is where I'm going to think there might be a few issues for me to do that, but who knows. But finding a dual pole single throw switch, a little tiny one like that, at a reasonable price, you know, we're back to the old problem of how much, how many do I need to buy? You've got to be kidding. So I want to keep it simple. So we'll leave the reset part of this whole project for another day, whenever I get around to it. But all right, when I've worked it out basically, and see if we can do it with this single switch as they show here, but the one in my circuit. However, just taking a step back from that, I think we've shown that at least this circuit can be used to power on and intelligently, gracefully power down again Don't use these big whopping great big MOSFETs. Use that dual MOSFET that I showed you last week or something similar. There's quite a few out there actually, but certainly the one I showed you last week on that little tiny breakout board I think is a good little thing to play with, because you've got access to all the pins, you don't have to do any soldering, and just logically getting it right. It's a nice thing to have. I found the one I've got here very useful. Funnily enough, when I dragged out this breadboard, I still had this circuit on here from months ago. So I thought, oh, let's use that again, see if it works. And lo and behold, it does. Right, okay, I'll leave you with that there. I'm going to put links down below for the PDF for this data sheet, the Aliexpress where you can buy it, and radio spares if you so choose. And of course, there's plenty of people who obviously do buy it. Buy the real 500 a piece. Yeah, if you could put your comments down below, any suggestions, alternatives perhaps to this chip that's, you know, a tenth of the price would be useful, or alternative just ways of doing it. Or am I just going down the wrong path? Do we think, oh, let's just keep it simple and just switch the thing off at the mains and that'll reset it, which it will, won't it? Okay, I'd love to hear from you. It's really great to have your comments. It takes me a little bit longer these days to reply to them because I'm sort of squinting. Oh, you can't see. So I'm squinting like this, trying to look at the video. And yeah, I don't wear these normally. No, not unless I go into town, of course, or something like that. So yeah, and if you think this was a fun video and you learned a bit, give it a great thumbs up, because after all, it's not for my ego. This is purely for YouTube to tell them, yeah, I quite like that video, because then they go, oh, people liked it. We'll give it out to more people. Always useful. That's it. I think we're done for this week. Nice and short. Well, I hope this is short because my eye's aching now. So see you next week. Hope you liked all the Christmas stuff. Thanks for watching. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.